Hi guys. Today we're not going to take notes in our factoring book. So if you want to go grab your spiral, we're going to take notes in our regular notebook. So if you have a spiral notebook or you just take it on regular paper, go ahead and take notes on that today. We're going to continue with factoring by the box method, not grouping today, but we're going to do some real life examples. So we're going to do some area and volume problems. Now remember that in this chapter, we're working backwards from what we were doing in last chapter. So last chapter, I gave you the dimensions and you had to multiply it out to find the area. In this chapter, I'm going to give you the area and then you're going to have to find the original dimensions. In this chapter, we're just going to be working with rectangles. The formula for area of a rectangle is length times width. Again, in this chapter, I'm giving you the answer. So I'm telling you what the area is, and I'm asking you to find the original dimensions. What was the length and what was the width? What was the original multiplication problem? So the area is written in the purple typing, and I made it a little bit bold so you can see it a little bit better. So to solve this problem, we're going to factor. So you can use the box method. And since this is area and we want length times width, we're going to expect to get two answers. If you're feeling pretty confident about the box method, which we learned yesterday, go ahead and try this problem right now. So pause the video and try it on your own. If you're getting a little bit stuck, I'm going to help you out. So this problem is a little bit different than the ones that we were doing in our factoring book. In our factoring book, everything was written in standard form or descending order, where we started with our largest exponent and we went down to our smallest exponent. In this problem, the numbers are kind of mixed up and jumbled up. So if we take these and we put them in the box exactly how they appear, it's actually not going to work. And so when you're putting the terms in the box, you are allowed to rearrange the order if it's not working in the order that it was given to you in. Here's the order that I did. When I was rearranging my terms, I made sure to put things next to each other that had something in common and on top of each other that had something in common. So I went ahead and I kept the AB first. And then next to it was supposed to go to the -2, but -2 and AB don't have anything in common. So instead, I decided to put the A next to it because now both of those boxes have an A in common. When I was looking for my second row, I again made sure to line up vertically my terms that had something in common. So you'll see I had my AB already right here. So I put underneath it the other term with the letter B. So the -2B goes below it. And then the only one I had left was the -2. Now it's okay that the A and the -2 don't have anything in common. That just means you're going to put a 1 there. But we do still have something in common in that second row, which is the -2. And so I hope if you tried this on your own, that for your final answer, that you got the dimensions were A minus 2 by B plus 1. The length, it doesn't matter which one is which, but the length can be A minus 2 and the width can be B plus 1. Here's one more area problem just to make sure we are getting it right. So here, again, I've given you the area. I wrote it in the bolded purple typing. And I'm asking you to find the original dimensions, the length and the width. Remember, we should get two answers. Something times something else. If you want to pause the video right now so that you can make sure that you try it on your own first, go ahead and pause. If you're struggling, I'm going to help you out a little bit. Now, this problem only has 3 terms in it. So we're not going to use the box method for it because the box method needs 4 terms because it has 4 boxes. So we're going to go back and we're going to do what we learned on our Tuesday notes, which is factoring out a GCF. Now you can just straight up factor out a GCF if you want to, or you can use the box method, but it's not going to be the 2 by 2 box. Instead, we would make it a 1 by 3 box. And we would need to find something that all 3 terms have in common. 8, 24, and 16 are all divisible by 8, and each box also has a letter G. So 8G would be my GCF. That's going to be one of my dimensions. Look, it's even lined up along the side of a rectangle to designate that it's a dimension of that rectangle. Next, we need to figure out the top. So for the top, I have a g squared, a minus 3g, and a minus 2. And that's going to be my second dimension, g squared minus 3g minus 2. Great, this can be our width, and this can be our length. And so that's our final answer. This is the end of our first video. In our second video, we're going to learn about factoring to find the dimensions when given the volume.